Hello students, let us continue the session on revision in the chapter areas related to circles. 12th question in the figure 11.11, arcs are drawn by taking vertices A, B and C of an equilateral triangle of side 10 cm to intersect the sides BC, CA and AB at their respective midpoints D, E and F. Find the area of the shaded region. Since it is an equilateral triangle, all these angles will measure equal to 60 degrees. Since D, E, F, they are the midpoints, each of these will become 5 centimeter. Now if you observe, this becomes sector. There are 3 such sectors, so the area of the shaded portion will be equal to the area of 3 sectors. So area of shaded region equal to area of sector multiplied by 3 times. So we get 3 times of the angle is 60 degree upon 360 degree multiplied to 3.14 into the radius square, which is 5 times 5. This will be 6 times, 3 2 times. Finally, we get it as 1.57 multiplied to 25. This divided by 2 will be 1.57 multiplied to 25. This will be equal to 39.25 centimeters square. This is the area of the required shaded region. Question 13. Figure 11.12. Arcs have been drawn with the radii 14 centimeter. This radii is 14 centimeter with the centers P, Q and R. Find the area of the shaded region. If you observe carefully, this is a triangle. They have not given what type of triangle is that, so we don't have the measurement of the angle, but then we can consider the angle subtended at this particular point as theta 1, let this be theta 2 and this be theta 3. We all know that by the angle sum property, the sum of these 3 interior angles is 180 degree. This is what is known to us. Now if you observe once again, the shaded part, they are the sum of the sectors, sum of the areas of the sectors. So area of shaded region is equal to pi times r1 square theta 1 divided by 360 degree plus pi times r2 square theta 2 divided by 360 degree plus pi times r3 square theta 3 divided by 360 degree. Now there is 360 degree common and pi is common, and if you observe the radii, they are equal, so 14 square is common. So the rest of the thing is theta 1 plus theta 2 plus theta 3. That particular sum is equal to 360. So 360 they get cancelled. What we get is 22 upon 7 multiplied to 14 multiplied to 14. This will be 2 times. So 22 multiplied to Sorry, I made a mistake here. This will become 180 by 2, isn't it? 180 by 360. So it is 2. That 2 will get cancelled with this 2. 22 into 14, which is 308 centimeters square. This is the area of the shaded region. Question number 14. A circular park is surrounded by a road 21 meter wide. If the radius of the park is 105 meters, find the area of the road. Here it looks like a concentric circle. Since it is a circular park surrounded by a road, both they are circular in nature. The radius of the park is given, it is 105 meter, and the road is 21 meters. So we have got the two radii. Let me call the larger one as R2 and the smaller one as R1. So here the area of road will be area of the park along with the road minus the area of park. That is pi r2 square minus pi r1 square. Since pi is being common, I'll take that as common thing. Radii 2 is 105 added to 21, which is 126 minus 105, and this has to be squared. Let me make use of the identity a square minus b square, that's 126 plus 105 times 126 minus 105. So 22 upon 7, and the sum is 231 and the difference is 21. So 7 3 times is 21. 3 multiplied to 22 is 66 times 231. Let's multiply. We get 15,246 meters square. This is the area of the road. Next question, it is similar to the previous one of the question we solved. Here again the angles are not known, but they have given that it's a quadrilateral. They have not given this particular thing as a square or a rectangle, but then the radii are equal. The radii is 21 centimeter. Let me call this as R. As we had done it earlier, the area of shaded region will be equal to the sum of the areas of all the sectors. Here sector 1 area is pi r1 square theta 1 by 360. The same with r2 square theta 2 by 360 plus pi r3 square theta 3 by 360 plus pi r4 theta 4 r4 square by r4 square theta 4 by 360. Here pi by 360 degree I can take it as common, and r square can be taken common because all the radii are equal. What we get is theta 1 plus theta 2 plus theta 3 plus theta 4. In this particular case they get cancelled because the sum of the interior angles is 360. So 22 upon 7 multiplied to radius square is 21 into 21. So it is 22 times of this will be 3 times 63. 23 multiplied to 63 is 1386 centimeters square. Question number 16. A piece of wire 20 centimeter long is bent into the form of arc of a circle subtending an angle 60 degrees at the center. Find the radius of the circle. Here the wire is bent to form a sector. Here the angle is 60 degrees. We need to find out the radius. The length of the wire is, say, L. Here the length of the wire is given by 2 pi r times theta by 360. So it is 20 centimeter they have given. It is 2 times pi. I'll retain as it is. Theta is 60 degree into the radius divided by 360 degree. This will become 6 times to 3 times. When you cross multiply, we get the radius as 60 upon pi centimeter. Now we shall move on to the next exercise. The first question of the next exercise is, the area of a circular playground is 22,176 meters square. Find the cost of fencing this ground at the rate of rupees 50 per meter. Here the area of the circular playground is given. The area is 22,176 meters square. Since it is circular, I know pi r square is 22176. So r I can find. So r square will be 22176 into 7 divided by 22. This will get cancelled. What I get is r square equal to 7 multiplied to, let's divide this. This will be 1008. Let me check again. Yes, it's correct. So r I need to find. It will be root of 7 into 1008. We need to find the root. For that I will use a prime factorization, and I'll express this as this will be 2 multiplied 4 times into 3 multiplied 2 times into 7. So the under root, so it comes out as 2 square multiplied to 3 multiplied to 7. This will be equal to 84 meter. So the length of fencing equal to circumference of circle. The circumference of circle is 2 pi r. This will be 2 times 22 upon 7 times the radius is 84, and we get it as this will be 712 times. So 24 multiplied to 22. Hence the cost will be rupees 50 to be multiplied with 24 and 22. We get it as rupees 26400, 26,400. Next question, question number 2. The diameters of front and the rear wheels of a tractor are 80 centimeter and 2 meter respectively. Find the number of revolutions that a rear wheel will make in covering a distance in which the front wheel makes 1400 revolutions. Here, whatever the distance is traveled by the front wheel will be same as the distance traveled by the rear wheel. Here, the front wheel has got the radius equal to 80 centimeter. In terms of meter, it will be 0.8 meters. And the number of revolutions it is making, I'll call this as N1. This is 1400 revolutions. For the rear wheel, the radius, I'll call it as R2. They have given it as 2 meter. I need to find the number of revolutions. Here, the distance traveled by front wheel will be same as the distance traveled by rear wheel. What is the distance traveled by the front wheel? Since I have taken it as R1 and N1, the distance is 2 pi R1 N1. This will be equal to 2 pi R2 N2. Let's cancel this 2 pi out. 2 pi is getting cancelled. I get N2 as R1 N1 divided by R2. This will be equal to 0.8 times 1400 divided by 2. On simplification, we get it as 560. So number of revolutions made by the rear wheel is 560. With this question, I'll end today's session. We shall take up question number 3 onwards in the next session. Thank you.